Part C. Determine the times at which the passenger is 23 meters from the ground. So here I've drawn the line at 23 meters approximately, and it's 23 meters on the way up and on the way down, and we want to find the T1 and T2 when that happens. Okay, so we need to essentially solve this equation. So solving this equation, I'm going to set this up. The height is 23, and I make it equal to the function that we've determined, and I'm going to solve this algebraically. So the first step is I'm going to subtract 16 from both sides, and I end up with 7 is equal to negative 15 cosine 2 pi over 120 times t. I'm going to get rid of that minus times by negative 15 by dividing both sides by negative 15. And I end up isolating the cosine. And then to solve this, then I'm going to use an inverse cosine. So the inverse cosine of negative 7 over 15, that's going to be equal to my theta 1, okay, which is my 2 pi over 120 t. So from my calculator, I end up with this value equaling approximately 2.06. Now this represents the time on its way up. So when I solve this, I'm going to times by 120, divide by 2 pi, and I end up with a time of 39.27 seconds. So algebraically solving this, we know that T1 is occurring at 39.27 seconds. Now we have to be considerate of the other angle on the way down, and that's where the theta 2 comes into play. So theta 2 is going to be equal to 2 pi minus theta 1, and that works out to be, my theta 1 was I'm just going to highlight this, 2.06 represents my theta 1, so my theta 2 I'm going to calculate as 4.23. 4.23 radians, and that's going to be equal to that angle 2 pi over 120 t. Okay, so this whole expression represents my theta 1. So that's theta 1. This is my theta 2. Solving for that t, I'm going to times by 120, divide by 2 pi, and I end up with 80.73 seconds. And that represents the time on its way down. So T2 is at 80.73 seconds. So I've just set the y value to 23. I solve this equation algebraically. I need to make sure that when I use the arc cosine, I solve for theta 1 and theta 2. And again, maybe I'll highlight theta 2 here. Theta 2 is in red there, and that's going to be this solution. Theta 1 is this solution here, gives us that solution there.